Good afternoon and welcome back to Computer Science 311. We are in the middle of our discussion of multi-way trees. The last tree that we talked about were these 2, 3, 4 trees. Let me get the proper tool here. 2, 3, 4. And you may recall that the way that we describe that is reference, data, reference, data, reference, data, and then a reference. So there would be D1, D2, D3. This was reference 1, reference 2, reference 3, reference 4. An invariant of these things was that the number of references was always equal to the number of data plus 1. If there was one data item here, there'd be 2 references, 2 data items, 3 references. Now we come to a 2, 3 tree. This is going to be pretty easy and actually pretty quick. And the difference here is just as follows. I'm sure you could almost guess what it would be. We'd have a reference, data, a reference, data, and then a reference. So there would be D1 and D2. And again, there would be R1, R2, and R3. And that's it. We're almost done. Now we just have to talk about how do these things grow. How do 2, 3 trees grow? Okay, and it's very similar to what we saw for 2, 3, 4 trees. First of all, new items. New items are inserted in leaf nodes down at the bottom. Okay, and the other thing to note here is that when a split occurs, okay, the value to be inserted is involved. That's a little bit different than it was with 2, 3, 4 trees. The other thing to note about 2, 3, 4 trees is remember, 2, 3, 4 trees, we always did a split as we were inserting, as we made our way down the tree. If we found a node that was full, we went ahead and split it and then continued. It's going to be a little bit different with 2, 3 trees. With 2, 3 trees, we only split once we're down at the leaf node where we want to insert, and then we're going to see that things will propagate back. So this is probably best exemplified with an actual example, and so we'll just go ahead and we'll actually give an example here. So let's say that we want to create insert the following values. So I say 10, 20, 5, 30, 7, 40, 50, 6, and 90. So to start off, here's 1. So that's going to give us, and again, I'm going to be very informal in how I draw these things. So that would be 10. So this is 1. And then we're going to come over here to 2. So this is 2. And now we would have 10 and 20. And of course, what's implied here, null reference, no reference, no reference, no reference, no reference. So now we come over here to 3. And here's where things get a little bit interesting. So at 3, what I've got to do here is I've got to insert a 5 into this. So I've got 3 values here. This is very similar to a 2, 3, 4 tree. So it's 5, 10, 20. The 10 is going to get kicked upstairs. Okay, so I come over here now, and I now have this situation here, where there's a node here that's got a 10 in it. And then what is going to happen over here is now I have a node over here that's going to have my 5 in it that got inserted. And then there's going to be a node over here with 20. And again, null, 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 and null. So now I want to come over here and I want to insert a 30. So at 4, okay, I come down here, 10 is going to take me to the right, and I see a 20 there, and I'm going to put a 30 in, and there's no problem. So I come over here, and this is going to look like the following. Here's a 10, here's a 5, null, null, over here is a 20, and a 30. Again, no problem. Null, null, null. Okay. Again, here we up over here, number 5. I want to insert a 7. I'm going to come over here. I will go down to the left. I'm in this node, and I see that I've got a room there to put the 7 in. So that's no problem. So for number 5, it's over here, and it looks like the following. Here's a 10. Coming over here is going to be the 5 and the 7. Null, null, and null. And over to the right here is going to be a 20 and a 30. Null, null, null. Okay, here comes an interesting one now. So this is number 6. I have to insert a 40. And we can see what's going to happen here. The 40 is going to take me down to here. The minimum the median value, the middle value of 20, 30, 40 is a 30. So the 30 is going to get kicked upstairs. Okay, so when the 30 gets kicked upstairs, I've got this. I've got 10 and 30. Over here, there's going to be a 20. Over here, there will be the 40. Over here, there is going to be the 5 and the 7. Like that. No, 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 and no. Everybody okay with that? Notice again what happened here. The 40 was over here. I wanted to insert a 40. The 40 was the median value. I take the middle value. I'm sorry, I keep saying the median value. 20, 30, 40. I take the middle value there, which is a 30. I'm going to kick that upstairs, and then the 20 and the 40 are going to be made into separate nodes there. Okay. So now I am at number 7. And I want to put in a 50. So we can see right over here, that's going to be pretty easy. It's just going to get inserted right over here. So at 10 and 30, over here, I've got 5 and 7. Okay, over here, I've got a 20. And over here, I'm going to have a 40 and a 50. Okay, number 8, I've got to insert a 6. So what's going to happen over here, okay, so this one is very interesting. When I'm going to insert a 6 over here, well, the 6 would be the middle value of all of these. So I'm going to split these, so there'll be a 5 and then a 7. The 6 is going to get kicked upstairs. And then what's going to happen over here is I'm going to have 6, 10, and 30. So the 10 is going to get kicked upstairs. So let's see if we can remember all of that. So we said that, first of all, when I come over here, I'm inserting a 6. So when I insert a 6, what's going to happen is the 5 and the 7 split. So I've got a 5 over here, and I've got a 7 over here. And what happens now is the 6 goes up to here, and now I've got 6, 10, and 30, so what's going to remain over here is 6 and 30. Like this. And you can see that this is less, this is greater, and there is going to be a 10 up here. Wait, did I do that correctly? Sure. I put a 10 over here. Oh, I made a big mistake. Big mistake, and I hope you all saw it. What happened is I forgot to split another node. So let's erase this. Let me make this bigger. This will all go away. You know, there's an easier way to do this. Let's talk this through very slowly. Okay, so I'm inserting a 6 over here. So when I insert a 6, what's going to happen, 6 is the middle value. I'm going to split, the 6 is going to get kicked upstairs, and the 5 and 7 are going to split. So I've got a 5, and I've got a 7. Like that is a 6. Now when the 6 gets kicked upstairs, I've got 6, 10, and 30. So what is going to happen is the 10 is going to get kicked upstairs, and I'm going to come over here, and again, I've already made a mistake. This is not a 6. This is a 7. Okay, what's going to happen is the 6 got kicked upstairs, the 10 is going to get kicked upstairs, and I split the 6 and the 30. So there is a 6 here, which looks like this, and there is a 30 here, which looks like this. Yeah, this makes sense. And then up here, there's a 10, which looks like this, and the left side goes there, the right side goes there, this goes here, this goes there. Okay, that makes much more sense. Then, of course, what happens over here with the 30 is on the 30 on the left side is my 20, and on my right side is my 40 and 50. That looks much better. And now, let's go to the very last step here, number 9. Okay, I'm going to come over here, and I am going to insert a 90. Okay, so 40, 50, 90 means I am going to split the nodes. There's going to be a 40 and a 90, and the 50 is going to get kicked upstairs. I don't need to split this anymore, so it's going to be over here is a 30 and a 50. What's going to be over here is a 20. What's going to be over here is a 40. What's going to be over here is a 90. Like that. Okay, I come over here. Here's my 10 again. It's like that. Here, 6, 5, and 7. Okay? And this was step number 9. So I hope that was clear. What would be very instructive here for you all to do is, I don't know, let's insert 100. I'll leave this as homework. And I'm going to say, insert, why don't we come over here? Here's a 50. Why don't we insert a 60 and an 80? And the reason why I said that is I've got to come over here, okay, and you'll be able to insert the 60. When you do the 80, there's going to be a split. You're going to come up here. This is going to be full. There's going to be a split. You're going to come back up here. So that's what you should try for homework. Okay, I want to finish up this chapter. External indexed files. In other words, I think the question here is why 2, 3, 4 trees? Or why 2, 3 trees? And I can hear a neighbor's horn going, and it's very annoying. I hope you can put up with it while we explain this. Okay, so again, I want to go back to the assignments that you've had this semester where we had this big database file, and actually it was a big array, and we called this the database array, and then we came over here and we had these indexes like that. This was all in memory. What I want to do is I want to consider, I want these things to be what's called, I want them to be persistent. And in Java, you hear people talk about serializable. And basically, this is all just a fancy way of saying that we store it on disk. Now, we're not going to actually do this, but we're going to describe some of the ideas that are involved in doing this. And I do want you to recall back from your computer science 211 class that you had these files that you could seek. In other words, these were random access files. And in other words, you could really think of a file as this very long sequence of bytes. And you could think of these bytes as being numbered. And you remember that you could seek. And you'd come over here to a file pos. And this thing over here was an integer. And if you were to seek to 1000, it would come over here to the 1000th byte, and when you issued a read command, it would start reading from there. And then if you were to say seek 500, it would come over here to 500, and you could read from there. So in other words, what you could do, it's called random access because you didn't have to go through it sequentially. You could jump through it anywhere in here you like. Okay? So just keep that in mind as we start talking about this. So I want you to imagine that we're going to create some database file that the records are going to be very long. So here's record 1, or record 0. And I don't know, and again, at the beginning of this chapter, I said, why don't we suppose it's 1024 bytes? So here's 0, and here's 1, and it's another 1024 bytes. And here's 2, and it's another 1024 bytes. And what do I want to assume is that somewhere in here, there's an ID, and maybe it's 5 characters. And there's an ID, and there's an ID, Okay, and what I want to do is I want to create an index, and I want to do something like the following. Maybe the ID for this one is 21307. The index for this one is 50962 over there. And maybe the ID for this one over here is 44132. Okay, so first of all, these are going to be stored in some big database file. So basically, from byte 0 up to byte 1023, this is record 0. And then from here up to 247, this would be record 1. Okay, and then we go over here and we've got record 2. Everybody got it? And what I want to do over here is that I want to associate, I'm going to have an index record here that's going to look something like the following. So my index record over here would say something like 21307, and it's at an offset of 0. And over here for this first record, this is going to be an ID of what goes to 1023, so it started 1024. Oh no, I'm sorry. The ID is 509. I'm doing this all backwards. Let me erase that. So it's 509, and I can't read my own writing, 82. 50982. And that starts at 1024. This is 1024 here. And over here, there is something that looks like this, 44132, 44132, and that starts at 2048. Everybody get it? So I'm going to call these, I can call these my index records if you like. And what I want to do, we were looking at 2, 3, 4 trees. Why don't we make it something interesting? Why don't we make it a 2, 3, 4, all the way up to 50? Okay. So in other words, I want to consider records that look like this. Here's a reference, and here's data 0, and here's a reference, and here's data 1, and here's a reference, and here's data 2, and here's a reference, data 3, reference, and I think you all get this. And I'm going to go all the way up to, let's see, if I've made this 50, how many things am I going to get over here? I'm going to have, it's going to go all the way up to D49, and then there's a reference. Okay, so basically what's going on here is there are, maybe this only goes up to D48. I think that only goes up to D48. Because if it goes up to D40, from D0 to D48, it says there were 49 data, which says there could be a maximum of 50 references, which is right. Okay? Everybody got that? And what I want to assume is that each one of these things in here is one of these. Okay? So what it is it's an ID number and it's an actual reference into the big database file, the offset of where I can find that ID number. So first of all, recognize that this is 1, 2, 3, 4, 5. This is 5 bytes. And if this is a Java integer, then this thing over here is another 4 bytes. So this would be 9 bytes. Okay? So if I've got 49 of these, I've got 49 times 9 is equal to 81, carry the 8, 4 times 9 is 36, is 44. So that's how many bytes that is. And then I've got 50 references, and remember each reference is a 4-byte number, so it's 50 times 4. That's equal to 200 bytes. So if I add that up, this is 641 bytes. So that means that this whole thing right here is 641 bytes. Everybody okay with that? Now the next thing I want you to do is remember, so this thing has 50 references coming out of it. So if I wanted to make this a multi-way tree, I've got this thing over here with 50 references in it. So there are 50 references coming out of it. And let's suppose I took it down another level. So here's a whole bunch more of these things. So if there's one of these, there were 50 of these, and let's take it down even another level. So that there are a whole bunch of things down here. Okay, and how many of these would there be? There would be 50 squared of these. Okay, and I don't know, let's make it even interesting. Let's take it down one more level. So I take it down to another level, and there are 50 to the third of these. So that's a lot. Okay, first of all, this 50 squared is 2,500. I think, isn't that right? And if I were to multiply that by, that's 25,000, that's 125,000. Is my mathematics right here? So hang on here. No, I don't think my mathematics is right. This one node here can reference 50 records. So then that means over here I can reference, because there are 50 of these, but remember each one of these have 50, this can reference 50 times 50 is 2,500 records. Now I'm counting how many records can it access. So this one over here can access 125,000 records. And then this one down here is 6,250,000 records. Okay. Now the question I have is I imagine when I'm setting up this thing, I'm going to have two separate files. I'm going to have a file over here called the index, and I'm going to have a file over here that I'm going to call the actual database. Okay, these long records, these records right over here, this is the database. We saw this before. These things going like this. The index is going to be all of these things. And what I'm going to do is I'm going to look at these nodes and I'm actually going to number them. And this one's going to be 0. And this would be 1, 2, 3, all the way up to 50. And this is going to be 51. And it's going to go all the way up to 2,500 and whatever. And then we get down here and it's going to go even further. Now, this is not going to be small. Okay, so there's 1 plus 50 of these, plus 2,500 of these, plus, and then we have to multiply that times 50, 1,200. That's how many of these nodes there are. And remember, each one of these nodes, we calculated, was 641 bytes. So let's calculate how big the index is. So this is 25,000, 27,000. This is approximately 128,000 times 641. And what I do is someplace over here, I've got a calculator. Oh, what the hey, we can do this. 1, 2, 8, 1, 2, 3. And then there's a 4, so that's a 0, 0, 0, and that's a 32. Carry the 3, that's a 1. Carry the 1 is a 5. And then we come over 6, that's a 0, 0, 0, 48. Carry the 4, that's 12 plus 4, that's a 6. Carry the 1 is 7. We add this up. 0, 0, 0. That's an 8. That's a 4. 0, carry the 1 is a 2. Carry the 1 is 8. So I come over here and I go 1, 2, 3, and I go, oh my goodness, that's big. That's 82 megabytes. And that's just the index. Okay, but the thing is take a look at over here. We said how many records is that accessing in the main database? Well, in the main database, it's accessing in excess of 6 million records. And each record, so that's 6 million. So that's 6 million. And each one was approximately 1,000 bytes. That's 6 billion. So that's 6 gigabytes. So in a way, if you think about it, the index is not that big compared to this. In fact, if you take, this is 6 gigabytes, this isn't even 100 megabytes. If it were 100 megabytes, it would be about 2% of the size. This thing is tiny. It's about 1% the size of the whole thing. Okay? Now, you have a couple of design decisions here. If you feel that these numbers are too big, you don't have to take this thing down to 4 levels. But now here's the thing that I want to get to here, because we're not completely done here. And it looks like I need one more thing to write on. And there it is. So we've got this index that looks like this. And now I'm looking at it out on disk. And remember, over here is our level 0. And then over here, and it's a bit bigger, is level 1. And then over here, a bit bigger, is level 2. And then over here, and it's even bigger, is level 3. And here's what I say to do. I say take this, and here's main memory. Okay? And main memory, I'm going to keep 4 different levels in here. Now remember, these guys are broken up into little pieces. Each one of these is a node. So I'm going to keep level 0 here. And remember, this thing looks like this. And I'm going to keep level 1, level 2, level 3. And what I'll do is I'll take the first level 1, which is right here, and I'll read it into here in main memory. And I'll come over here to level 2. Let's make some dividing lines here. Here's level 2, and I'll take the very first one of these, and I'll read it into there. And let's come over here to level 3, and let's take the very first one, and we'll read it into there. And now what happens is somebody comes along and they say, okay, the key is equal to, and I make something up here, 89163. And what we need to do is we need to find it. So first of all, we come over here and we start reading all the data. And we read this data. No. Now remember, each one of these is going to be sorted. And at some point, I'm going to get over here, and if I am lucky, 89163 would be right over here. Now, if it's right over here, remember the way it's written is here's the key, and over here is the offset into the file. So I would have the offset into the file. But if I'm unlucky, and this happens to be the first key that's greater than this, then this is giving me a reference in the multi-way tree to the node that I should now follow down. Now, one of two things can happen. This node that it's pointing to is either going to be this one right here, but if it's not this one, it's one of these other ones in here. So at the very worst, I might have to do a replacement here. At worst, one replacement. And now, suppose I have to do the replacement. Now I start searching through here. If I'm lucky, I find this key. If I'm unlucky, I'm going to come upon a key that is the first one to be bigger than it, and it's going to give me another reference, okay? And it's going to say, all right, this is where you need to go. And it may be the case that this reference is this one that's already in here, and if it isn't, it's going to be one of these other ones. So I would have to, at worst, do another replacement. And I think you can see what happened. Now I would start looking through here, and if I'm lucky, I will find the key that I'm looking for. If not, I'm going to find a link to where it is at the next level. Okay, if I'm lucky, that level is already in here. If not, I come over here and I read it in. Okay, so here's going to be one more replacement. So here's the key here. In this database here, and I want you to recognize how big this database is. This database is huge. We said this was a 6 gigabyte indexed file. I'm looking for where we did the actual calculations, and I can't seem to find it. I think I saved it somewhere. Okay. What's going to happen here is that at the very worst, this is always going to stay in main memory. This would require a disk access. This would require a disk access. This would require a disk access. And finally, when I'm looking in here, it's going to give me the access into the database file. So at worst, 4 disk IOs to find the desired record. That ain't bad, okay? And that's where you'll find that multi-way trees are used very frequently in implementing these indexed. There's sometimes, back in the old days, they used to be called ISAMs, and that stood for Indexed Sequential Access Method. I haven't heard that term much lately. But it's a way of implementing an indexed file on disk. And that, my friends, is the end of the chapter. I hope you enjoyed it.